Okay, quadratic inequalities. You can solve them graphically or algebraically. We'll semi-solve it graphically first, just to sort of get an idea what we are looking for. And so let's look at the first one. It says 2x squared minus 7x minus 4, that is this particular parabola, needs to be above or greater than 0. Well, what you have here on the right side, that is the function values that you're looking for. So we're actually being asked to solve this. When is the function value above 0? Well, graphically that's pretty easy to see. 0 means that you are right here. And so you can see that above 0, well, that happens for two regions of this graph. That happens if you have an x that's larger than 4, or that happens here when you have an x that is less than, and in this case we're not really, I wasn't really going to try to solve it algebraically, but if you factor this you end up with a negative 1/2. So you can sort of see where that happens here. So that's that's one question that can be asked, and we actually have two answers, or two intervals. Excuse me. So let's look at the next one. So in red, same thing again, but now we're being asked less than or equal to 2. So let's see if we can get a line that's pretty close to 2. So we'll try that. Okay, so we are looking for the function. So this is the function, and we want the y values to be less than 2. So here and here we can see it intersects with 2. So less than 2 means that we need to be between this x and this x. And again, I don't want to solve it algebraically, but you know, let's say that that's just to the right of a negative 1. So we would have, well, x needs to be greater than, you know, let's say it came out as a negative 4/5. And this one's slightly more than 4, and so then you would have x is less than or equal to, actually in this case, less than or equal to 9/2. So that could actually be written as a set. So if those were the two right numbers, you could also answer this question by giving me an interval, a set notation. Okay, all right, last one. Should have a purplish somewhere over here. Okay, so negative 81/8. I'm willing to bet that negative 81/8 is the vertex over here. Okay, actually I know it's the vertex. So we are being asked for the function to be greater than the negative 81/8. So that's a negative 81/8. And the graph touches right there. So when is the function above that line? Well, almost always. It's above it over here, and it's above it over there. Let's see if we can actually find the x value here, because that's just the vertex, right? So the vertex would be a negative b, so that's 7 divided by 2 times 2, 2a, so that's 7/4. So this is 7/4. Okay. To the left of 7/4, the function is above the line. To the right of 7/4, the function is above it. It's not above it right here. So this one's sort of a weird answer. You can do it different ways. You can say x needs to be less than 7/4, or x needs to be greater than 7/4. You could say it's all real numbers except x cannot equal 7/4. You have to exclude it. Or you can say it's from a negative infinity to 7/4 with a round bracket, and then starting at 7/4 out to infinity, and that will be possible as well to write it that way. So you have some choices here, but just keep in mind that you cannot include this point here. Now if I included it this way, if I said greater than or equal to, then you'd have to say, well, that's true for all real numbers, because it's always above or equal to a negative 81/8. Okay, usually we don't. Most of the time you're going to solve these algebraically though. Okay, so let's see what we have here. solve the inequality, negative 2x squared less than or equal to 4x plus 5, and graph the solution set. I would bring everything to the right, to the left. Let me write in a different color. That might not show up very well for you guys. Has to be less than or equal to 0. It's sort of difficult to solve this as an inequality. So one thing that you can do here is think of this as just an equation. So think of this as a negative 2x minus 4x minus 5 equals 0. And then, quickly put a graph together for this over here. Well, and what I mean with quickly put a graph together is that you know that it does this. Okay, and then that kind of a picture will help you when you actually try to answer this. So, factor the negative out. So that's 2x squared plus 4x plus 5 equals 0. I have a feeling this one might be factorable. So let's start with 2x. So 5 would be 5 and 1. I'm not seeing that work, am I? So maybe it's not factorable. Okay, I don't see an immediate factoring. Negative 4 plus or minus the square root of b squared. That's 16 minus 4 times a times c divided by 2 times 2. That's a negative 4 plus or minus the square root of, that's 10. 16 minus 40 is a negative 24. And that's enough at this point to sort of tell you that this thing will never be equal to 0. Okay, so it's an imaginary square root, so there are no solutions for 0. But that means that the graph that I just tried to sketch you looks a little like this. This thing is always below the x-axis. And that's really what we're being asked here. When is this inequality, or when is this function less than or equal to 0? When is it below the x-axis? So the final answer is going to be always, all real numbers. Graphing the solution set there, it's sort of silly, but you end up just graphing the number line and putting a line on top. Solve the inequality and graph the solution set. So let's see if this one is factorable. And again, I'm going to solve this for an equal sign. So what do we need? We need a 2 here and a negative there. So negative 1, negative 2. But that doesn't work, because that's only. So let's try it the other way. So if I make this a negative 2, that gives me negative 4. Minus 1x is a negative 5x. Okay, so solving this gives me 2x is equal to 1, x is equal to a half. Here I get x is equal to 2. Quick little sketch for this thing. So at a half I get a 0, and at 2 I get a 0. Overall the graph will look a little like this. And I want to know when it is above. So it's to the left of a half, so x is less than a half, or x is greater than 2. Graphing the solution set would look like this. At a half, open circle, we're going to the left. At 2, open circle, and we're going to the right. Okay? So graphing, solving inequalities, quadratic inequalities, my suggestion is that you actually pretend that you have an equation. Okay? So I would solve the equation, and then I would link it. I would link your answers to that part to a graph. And based on the graph, you can tell me what the inequality would be. All right? Thank you.